So before we look at K-maps and move further, let's look at some more Boolean algebra-based simplification. By the end of this video, you should probably have a strong motivating factor to learn K-maps. If you don't really have this background, you're gonna be like, K-maps are that's disgusting. I'm not gonna learn this, but you'll see why. Because stuff like this, something like this equation, it's not really trivial to solve it by hand. So just looking at this, what do we see here? So we see that we have a b on this side. So we have these b terms here and here. So we want to preserve those terms, right? So we want to prove that this is true. So we want to preserve those terms because all of the other terms, as we can see, have seemingly disappeared. So we have to figure out a way to sort of absorb the rest of them into whatever, right? So you might be really inclined to sort of just simplify this whole thing and multiply it out, but that's while that works with regular algebra because you're so familiar with it. Since you're so new to Boolean algebra, you sort of want to not do that and like work yourself into a roadblock. So let's look at this term here. So we see that this is an R and the inner terms are knotted. So what does that tell us? That's a really easy case for Boolean algebra, right? So if we just, instead of writing it out with an R like that, if we just instead take that knot outside and just add them on the inside, we get a term that looks like this. So let's write out the rest of the equation. So we have ACD plus A. Oh, let me fix that. So we have ACD A times CD naught plus B, and then the rest of the equation. So this is by De Morgan's law. De Morgan's law. Cool. Now what do we see? So we see that we have a CD term and a CD dash term. So when you say, okay, I have 1 or 0, right? So 0 is just the reciprocal of 1, right? So it's just the opposite. So if I say I have 1 or 0, that's a 1, right? From the truth table of an R. In the same way, if you have A or not A, that's like saying, okay, I'm going to do this thing regardless, right? So this just becomes a 1 always. So that's just an identity that you have to remember. So we see that we have these two terms here. So we're going to think of how we can sort of use that to our advantage and sort of just get rid of that term altogether, because that's kind of nasty and we don't want it for the final solution. So let's pull out the A and then just do CD plus CD naught, and then again we'll write out the rest of the equation. Cool. What do we do now? We just brought out that equation, or the identity that we talked about. So now that we have that, we can just write this whole thing as 1. So you have A times 1, I'm going to put a dot there, plus B, and then A dash or A naught B, A naught RB, and then B. Cool. All right. Now for the fun part. So now we have a more sort of convoluted equation, right? So we have A plus B, and then we have that multiplied with an A naught and a B, right? So now we have to figure out what we can do to sort of, I guess, filter out that B, because that's all we want, right? So let's look at these internal A's again. So similarly to the previous step here, since we have an A and an A naught and they're ANDed, we can by commutativity, we can just say that they're, it's basically just like saying A or A naught, right? Because they're multiplied on the inside. So yeah, that's pretty much all we need to do, and we get a B. And then on the right hand side, we already have the B. Cool. Now, yeah, this is already getting pretty non-trivial, right? So hopefully you have a motivation to learn K-maps by now. If you don't, well, you will after this problem, hopefully. So this one's more involved. As we can see, we have more than just a single term on the right side. So we sort of have to work our way towards it, right? So let's look at the left-hand side and first figure out where exactly we have that term here. So for the left-hand side, let's see. So we have it right here. We have all of these auxiliary terms as well. So we've got to get rid of those somehow. So let's see. Where can we approach this from? So here we have this ABC appearing in both terms. So let's start by just factoring that out and then writing out the D and the D naught. So immediately we have a 1 here. And then, yeah, let's just write out the rest of the equation like that. AB. Cool. Yep. And now that we have that 1, we can just write this as ABC. And then A naught B, A naught RC equals BC plus A naught. Cool. Well, what else can we do now? So let's see here. So we have that ABC, and then we have the A naught B, and then the A naught on the inside. So right here we have the A naught B and the A naught. Let's try and play with that for a second. So ABC plus A naught B A naught plus A naught B C equals BC plus A naught. Cool. Alright, now it looks like we have ourselves a nice roadblock here. So what can we do to sort of fix this? Notice how we have 2 of the same term here. We can just sort of merge that and get rid of one of the terms. So let's do that. And now let's look at the rest of the equation. So in 2 of the terms here, we have a BC, right? And what do we see? What does that multiply with? We have opposing terms, right? So we can just pull out that BC, put an A there, and an A naught here. And then we have an A naught B equals B C plus A naught. Cool. Now we have a BC and an A naught B, and then on this side we have a BC plus A naught. So multiplying this out, we see that we have a BC here plus B A naught. So trivially, we can just go ahead and say B C plus A naught, and that proves the equation for us. But as you can see, that's a whole lot of steps, and we would like to try and avoid that. So K-maps would be a nice way for us to sort of visually do this, because doing this visually is a lot easier than writing this entire thing out. So the next video is going to be about K-maps. Yeah.